So, hello everybody, and let's discuss one of the relation in elasticity. That was relation between, please write, Young's modulus, bulk modulus, and Poisson's ratio. So let's discuss that relation between Young's modulus, bulk modulus, and Poisson's ratio. Again, bulk modulus जब भी आएगा तो you have to be careful कि the force is acting from all direction on the object. Then only bulk modulus will come. Bulk modulus comes there is a volume strain. There is change in the shape of the object. Then only bulk modulus comes. So let's say if I've taken a special case, but at this stage that is only we have to do. Okay, so I've taken a rectangular bar. Okay, so here this length is L1, this length is L2, this length is L3. Okay, length, breadth and height. This force is acting from this direction. Bulk modulus here, it's a compressive force along the, let's say this is X, this is Y, this is Z. Rectangular bar है, तो I hope सबको समझ रहा है. One force is acting vertically down. Again, throughout the surface it is acting. Remember it. This is, and the third force is acting on this surface. So we have three forces acting. Means it's a bulk modulus we have to consider. So you have to take forces from all direction. Okay, so like this here, one force is acting from here, second from the lower part, second from this side and from this side, third from this side and this side. So we have to get relation between Young's modulus, bulk modulus, Young's modulus, bulk modulus, and Poisson's ratio. This relation we have to develop. Poisson's ratio comes when there is a lateral change in the dimension with respect to longitudinal change. If you remember, Young's modulus comes for a longitudinal change in dimension, bulk modulus comes for the overall change in the dimension of the object. So we have to correlate this. So let's go one by one because it will be confusing. So let's say if only the red force is acting. So if I draw the shape again, let's say only the force along x-axis is acting. Okay, due to this force what will happen? So again you can see this force is perpendicular to, it is along L1, and this is perpendicular to L2 and L3. So just see this force along X. So due to force along X, the L1 is going to decrease. Means I am applying force like this. I am applying force like this. ऐसे मैं force apply कर रहा हूँ. दिख रहा है? So this length is going to decrease because it's a compressive force. So this length will decrease. जैसे ये length decrease होगा, ये length because of this force. So length along, this is X, length along Y and Z, this will increase because compress होगा तो ये length decrease हो रहा है, तो length along Y and Z, this length and this length is going to increase. Remember it. जैसे तूने force किया कि common you can visualize this, you apply this, so this length is going to decrease, this length and this length will increase. So because of this force along x-axis, it will change the dimension of L1 as well as L2 and L3. All three dimensions will be changed. Getting this? The same way, the force because of blue one, this will decrease the length of L2, but L1 and L3 will also change because of this force, and same for the force due to green. So let's see, this is due to this force, due to force along x-axis, I can write force, that is force by area, force along x-axis by area. This is Young's modulus delta L1 by L1, and it will be minus because length is L1 is decreasing because of force along x-axis. Okay. Now there is a lateral, again if you apply the Poisson's ratio, there is a longitudinal change in length. So for that there is lateral change in the dimension also. So for this I can write sigma will be minus delta L2 by L2 by delta L1 by L1, that is equal to minus delta L3 by L3 by delta L1 by L1. Just see. So because of force along the x-axis, L1 is going to decrease, and because of Poisson's ratio, the lateral distance, the lateral dimension is also going to change. And since this is decreasing, so this L2 and L3 has to, because delta L1 by L2 is negative. So this delta L2 by L2 will be positive, delta L3 by L3 will be positive. So these lengths, the length, lateral length is going to increase. So 3 length, so lateral length will increase here. So here, so here delta, so this one, if I write here, so delta L2 by L2 will be minus sigma delta L1 by L1, means L2, length of L2 will change because of force along the L1. Okay. Similarly, the delta L3 by L3 will also change because of force. So just see, this information tells you this delta L1 by L1 is changing because of force along L1, red one. So when this length is changing, that is also executing the change along L2 along L3, and that is the meaning of Poisson's ratio. So meaning what here, from here we can say, so net length means L1 का जो length change होगा, not only because of this, length of L1 will not change only because of force along the L1, but also force along L2 and L3. These forces, the green and the blue, these forces will also change the net length of L1 by the Poisson's ratio here. You can see here, the force along red, force along L1 is changing dimension of L2 and L3 both. The same way we can say the force along L2 and L3 will also change the dimension along L1, and that will be same. So if I just write it here, so I will just write here dimension, change in dimension of L1, change in dimension of L1 due to force along L2 and L3. Here this is change in dimension of L2 and L3 due to force along L1. These are the change of dimension along L2 and L3 due to force along L1. So here the same will be here, the change in dimension of L1 due to force along L2 and L3, and then if we add all this change along L1, that will net change of L1. So due to this change क्या हो जाएगा, तो sigma, so if I write here, so delta L1 by L1 will be minus sigma delta L2 by L2, like here, and similarly delta L3 by L3 will be equal to minus sigma, delta L1 by L1 will be minus sigma delta L3 by L3. This is the change in L1 due to force along L2. So these are the lateral changes because of force along L2 and L3. Force directions along L2 and L3. So these are the lateral changes. So if I just write the net change, so delta L1 by L1 total net, क्या change होगा? So this net change will be due to this, means delta L1 by L1 due to, this is due to force along L1. due to force along L1 plus delta L1 by L1 due to force along L2, and similarly delta L1 by L1 due to force along L3. Just see. So this all changes together is going to give you the net change in the L1. Getting this? So please write. तो ये लिख लो, मैं यहाँ से हटाता हूँ, ठीक है? So if I write it here, so we'll have here तो net change. So delta L1 by L1 total net will be what? This is here. That is, इसको मैं P लिखता हूँ because it is a hydraulic pressure, then only the bulk modulus will come. So it is minus P by Y because of this, it will be again अभी यहाँ पे ये निकालना होगा. ओके, उसके पहले मैं थोड़ा सा चेंज करता हूँ, मैं यहाँ थोड़ा सा मिटाता हूँ. मैं देखो ये तो ये तो समझा सबको, लिख लिया सबने. So now, so here this one, let's take this. So this is change in length of L1 due to force along L2. So due to force along L2, we can write here the same equation. We can write P is equal to minus Y delta L2 by L2. So from here we can write delta L2 by L2 is minus P by Y. Put this value here. So delta L1 by L1 will be minus sigma, minus plus हो जाएगा P by Y. Just see. And same here, if you execute this, तो L3 by delta L3 by, so this is delta L1 by L1 is equal to plus sigma P by Y. ये हो गया due to force along L3, change in the length of L1. So net change मैं यहाँ पे लिखता हूँ. So net change delta L1 by L1 क्या हो जाएगा? So that is the change in length of L1 due to force along L1 is minus P by Y plus due to this force along L2 sigma P by Y plus sigma P by Y. So this becomes minus P by Y is taken common. So 1 minus 2 sigma. Just see. This is net change in the length of L1. Fraction of change in the length L1 due to forces acting along L1, along L2, and here all forces are acting simultaneously because it's a exposed to hydraulic pressure. Forces acting because then only the bulk modulus will come. एक बार दो तीन बार को ये करके देखना, रिवाइज करके फिर समझेगा. Similarly, by symmetry we can say delta L2 by L2 क्या हो जाएगा? Minus P by 1 minus 2 sigma. And similarly delta L3 by L3 net change will be minus Py 1 minus 2 sigma. Okay, now we have to connect bulk modulus. Bulk modulus comes from the volume strain. ठीक है ना? तो bulk modulus here hydraulic pressure is P, so P equal to minus B delta V by V. अब here volume strain क्या होगा? It's a rectangular rod and उसके लिए हमने देखो किया था. तो delta V by V is delta L1 by L1 plus delta L2 by L2 plus delta L3 by L3. Put these values here. So P is equal to minus of B delta L1. Delta L1 is this. So that is minus P by Y. देखो ये minus P by, so ये 3 times हो जाएगा. Minus minus plus हो जाएगा, तो 3 times P by Y 1 minus 2 sigma. P cancels here. So here Y equal to 3 times of B 1 minus 2 sigma. Just see. And this relation we were looking for. इसको 2-3 बार करके देखना कि change in length of L1 will be because of forces along L1 as well as forces along L2 and L3 both. Because of forces along L2 and L3 there will be lateral change in the length by the Poisson's ratio. And this relation we were looking for. Go through it or don't ask in the doubt session. Thank you.